let's take a look at some examples. So we want to describe the transformation, and then we're going to practice graphing. We'll graph both our f of x and our g of x, our transformed function, and then we want to identify the domain and the range. So we're going to start with our parent function, and it's our square root parent function. F of x is equal to the square root of x. G of x is going to be square root of x minus 3, and then plus 4. So let's take a look at what is different. The first thing I notice that is different from the parent function is that I have a negative 3 under the radical. Remember that anything that happens inside the radical with x is horizontal. So we are going horizontal translation, and because I see a negative sign, that means that it's going to the right. So horizontal translation, right by 3. The other thing that I see is different is a plus 4 tacked on the end. Remember, when things happen outside, that's vertical, and it goes the direction you would think it would. So positive number is going to go up. So we have a vertical translation, and that is up by 4. So let's first graph our parent function, and I'll graph the parent function in purple. So let's go ahead and pick a few points for our parent function. So this is going to be our f of x. So we'll have an x and a y, and I knew that it starts at 0, 0. I saw that before, but I can prove that to myself by plugging in 0 here for x, and the square root of 0 is 0. If I plug a 1 in for x, I'm going to get an f of x or a y also equal to 1, because the square root of 1 is 1. I want to pick the next perfect square so that I can take an exact square root. So my next perfect square would be putting in an x value of 4, and I will get a y value of 2, the square root of 4. And then finally, if I go to the next perfect square, that would be 9, and that will give me a square root of 9 equal to 3. That's going to be all I can graph. The next one would be 16, and the square root would be a 4 for the y value. But let's go ahead and plot these points and do our graph. That's my parent function, f. Let's do the transformed function, which is my g of x. Let's do that in orange. So we will again pick some x and y values. Now I know that I have translated right by 3 and up by 4. So I can say for sure that my first point is at 3, 4. But let's prove that to ourselves. If I plug a 3 in here, 3 minus 3 is 0. So I get a square root of 0, which is, of course, 0. Plus 4 gives me a 4. Now I want to pick some more x values, and I'm going to go up by the same increments I did here. So I went from 0 to 1. That means I'm going to go from 3 to 4. I'm going to add 1. So at 4, I want to see what I have. 4 minus 3 is 1, and the square root of 1 is 1. Plus 4 is going to give me 5. And then I want to get the next perfect square. So I had a 4 minus 3 was 1. Next, I want to make this into a 4 so that the square root is 2. And in order to do that, x needs to be 7. So I'm going to plug in 7, and I will get a y value of 6. Let's plot those points. 3, 4, 4, 5, and 7, 6. And that gives me a few points to get my graph going. So this will be G. Let's talk domain and range. So our parent function has the domain that we talked about previously. So it's going to have a domain of x greater than or equal to 0 and a range of y greater than or equal to 0. But my transformed function, g of x, its domain doesn't start until x gets to 3. So it will be x is greater than or equal to 3. My range, I don't see the graph until I get to a y value of 4, and then it continues on to infinity. So y is going to be greater than or equal to 4 for my range.